Hi, I'm Salman Ushvar, and in this lecture I want to talk about Supermesh. I'm from Pattern Recognition Lab, and this presentation is for Electrical and Electronic Circuit lesson at the Ferdowsi University of Mashhad. Well, basically, what is Supermesh? Supermesh occurs when a current source is contained between two essential meshes, such as this circuit, for example. We have a current source here that is contained between two other meshes. How do we solve this question? How do we solve this circuit and analyze it? We have to first treat the circuit as if the current source is not there, and this will lead to one equation that incorporates two mesh currents. And once this equation is formed, we need another equation because we are not going to be able to solve one equation with two unknowns. And how do we form that other equation is by coming to this branch that we first ignored, the current source branch. And because I1 and I2 are simultaneously flowing through this branch, we can get another equation called the helper equation. And with these two equations, we can solve and analyze the circuit and find I1 and I2 respectively. So we're going to go and examine this approach in examples, and we will see how it will ease up our procedure to solve and analyze circuits compared to mesh methods. Let's review an example together. Consider this circuit. We want to find I1 and I2, and we will assume both of them are clockwise. By using mesh method, we're gonna have I1 and I2 clockwise as told, and we're gonna assume that the voltage across this current source is Vx. And by applying KVL to this loop, loop 1, first loop, we're gonna have 21 minus 6I1 minus Vx equals to 0. And by rearranging for Vx, we're gonna get 21 minus 6I1. And by applying KVL to this second loop here, we're gonna get Vx minus 4i2 plus 5 equals 0. And then again, by rearranging Vx, we'll get 4i2 minus 5. And based on these equations, we're going to equate them, and we will get, by omitting Vx, let's say, we will get 21 minus 6i1 equals to 4i2 minus 5. And we are not going to be able to solve this equation because we have two unknowns, I1 and I2. So we will needing another equation to solve it. As I told, we will get that equation from the current source branch, this branch here. So what we will get is I1 minus I2 equals to 1 because I1 and I2 are both flowing through this branch simultaneously, and we will get I1 minus I2 equals to 1. Now we have two equations for the two unknowns. By replacing I1 equals to I2 plus 1, we have 21 minus 6I2 plus 6 equals 4I2 minus 5. And we will get I2 as 2 amps and I1 as 3 amps. Now let's solve this problem using Supermesh. What it just did was using mesh method. Now by using Supermesh method, as we said before, we're gonna remove the branch containing the current source, which is common between any two meshes. And for us, in this circuit, this is the middle branch. As you can see in this picture, it is removed. And we have a large mesh called the Supermesh. Now we will apply KVL to our supermesh, and we will get 21 minus 6I1 minus 4I2 plus 5 equals to 0. Remember to don't forget the current source branch which we removed. Although it's not there when we removed it, but it's originally there. We just removed it to form our supermesh. And that's where we're gonna get our another equation, helper equation, to solve this equation, which is I1 minus I2 equals to 1. Then again, as you can see in this picture, it's the same. I1 minus I2, both clockwise, equals to 1 amps. So what do we have here? Okay, Now we have I1 as 3 amps and I2 as 2 amps. As before, the answer is the same, but the approach is very much easier. So we have an implementation of scheme draw here for our circuit. Feel free to pause the video and analyze the code if you want to. All right, let's move on. And here's a piece of Python code. You can analyze this one too. It's just basically for solving our equations, which will lead to the same answer as before. I1 equals to 3 amps and I2 equals to 2 amps. We will examine more complex examples in the next parts.